Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, it's time for round 2 of the Musical Paradise MP301 modifications. And this time we're going to finish doing the mods for the driver tube, changing the output tube, bypass capacitor, putting the shade feedback resistor, and then buttoning this thing up. I decided to go ahead and put a couple of Mundorf aluminum oil coupling caps in the amp too while I was inside there. These little box film caps, I have no idea what they are, who made them, whether they're any good or not, just to eliminate that as a possible problem. Since it's in the signal path, we're going to replace those, and they're about $30 for a pair from Metasound, and I'll put a link below to where you can buy those. So let's get into finishing this project up. Okay, we got our resistors out, and we're going to go ahead and solder in. There's a 470K grid leak resistor. I normally use a 510K, but some viewers were kind of panicking because I went 10K over the recommended maximum for an EL34 tube. So just to avoid drama, we're going to make this a 470K. So let's solder those two in. I'm going to flip the board over here. And again, I like to stand the resistors off from the board just a little bit. Trim off our leads here, and then we get all done, we'll clean off this flux before we put the thing back together. And again, this is the 4.7K dropping resistor for the front end part of the power supply, and this is our 470K grid leak resistor. We're doubling the value of this. I think it was originally 250K. It'll make the low frequency roll off of this capacitor much less. And then this 4.7K is much smaller than the original, which is going to jack up the front end voltage, which is what we want to see. So the next thing we're going to do is we're going to put in a 33K plate load resistor. And then instead of running the resistor from here to here, this is the screen of the driver tube. Instead of running it over to this voltage point and wiring as a pentode like it was originally, we're going to be connecting this point to this point. And you can see over here on this side, we've done from this point to this point here, where we've tied the plate of the input tube, and this is the shade feedback resistor that we're going to add later, and then this is the 33K plate load resistor. This is our 4.7K dropping resistor for the front end voltage, and this is our 470K grid leak resistor for the output tube. So let's put in our 33K plate load resistor for the input tube across here. As you can see, I used my little desoldering wick and cleaned the holes out. It just makes it a lot easier to work on. And then finally, we're going to use a 510 ohm resistor to triode strap this input tube, and we're going to put it in here. And I know you can't really see what I'm doing, but that's kind of necessity here as I solder this together. And one end of the resistor is tied to this lead on this resistor. Let me zoom in here and show you what this looks like close up. So we tied one side of this resistor to this leg here, which is hooked up to the plate of the tube. And then the other side comes over to here, and that wraps around and comes over here to the screen. And that's triode strapping the screen to the plate using a 510 ohm resistor. Pretty simple stuff. So let's solder all this up. I'm going to solder this resistor to this other resistor here first. And then we'll flip it over. And what that's doing is it's converting the driver tube from a pentode to a triode. And some say there's a little rule about good sounding single-ended amps. You want to use a triode to drive a pentode and a pentode to drive a triode. I don't know if there's a whole lot of truth to that, but I have found that all the amps I've built so far that really sound good follow that rule. The 300B I built ended up using a cascode, which is the sister to a pentode, to drive the 300B tube, and it sounded much better than trying to use a pair of triodes stringed together to drive it. Okay, so now we got all these resistors in place. We'll go over this one more time. This is a 470K resistor, goes from this point to this point. This is a 4.7K, goes from this point to this point. On this side over here, we have the same thing. 470K goes from this point to this point. We've got a 4.7K that goes from here to here. This is a 510 ohm that connects from this point and then ties to this point right here. And then we have a 33K that goes from here to here. And then the same thing over here. We've got a 510, goes from here, ties up to this point, which is the plate. And then we have a 33K that goes from here to there, and that's our plate load resistor. So the only thing that some people might panic about, and it's really not a big deal, is we do have to cut one trace because we want to add a screen stopper to the screen of the output tube to drop the voltage just a little bit on the tube. And to do that, we need to cut this trace right here. And you can see on this side, I cut this trace right here and put a resistor from here to that pin. Let's see if I can, if I get this way you can see it a little better. You can see I cut that trace right there underneath this resistor. And this is a 2.2K screen stopper that we're putting in this trace between where the ultralinear tap of the output transformer hooks up here and the screen. So we need to do the same thing over here. You want to put the resistor fairly close to the screen. So we've made up a little deal like this with some PTFE tubing on here. You could use some heat shrink tubing if you want. It's going to go from this pin here, come across and tie into that trace right there, and then we're going to cut the trace right there. So you get something like a little Dremel tool. You could actually get a screwdriver and just kind of gouge it out. You just want to break that trace. But we're going to use a little Dremel tool here. And actually, it doesn't matter where you cut it. You can see it doesn't take a whole lot to cut it. You can cut it here, there, wherever you want. It just needs to be cut somewhere between this point where we're going to be soldering and the pin. And then since we're going to be soldering it right in here, we need to scrape off a little bit of this paint or this clear coating here to get down to the copper. Now be careful, you don't want to destroy the trace because we have to solder to it. So be gentle with this process. Just like that. You just want to get enough to get that clear coat off. So you can solder to it. And then I'm going to go ahead and get a nice clean tip and come in here and make a little solder pad like that. We're going to come in and solder one end of this resistor down to the trace. Like that. And then we want to solder the other end of this resistor over here to our pin. Just like that. And now we've got this 2.2K resistor between the screen and the ultralinear tap on the output transformer. We've cut the trace here so it's no longer electrically directly connected. And what this is going to do, it's going to drop this screen voltage just a couple of volts below the plate. And I've found that it makes the output tubes much happier when the screen is just a couple of volts below the plate instead of the screen being higher than the plate. And I don't know, I found it just makes the amp sound nicer. So we've got the capacitor replaced, we've got all these resistors here done. We got this resistor over here, which is the cathode resistor for the input of the driver tube. That's the cathode bypass cap. Now we're going to put the output tube bypass cap in. Let's get this capacitor put in place. And this is the negative. You can look at the back here. See, this is kind of the ground bus that comes around the whole amp. This is coming straight off the cathode, so that is definitely our negative side of the cap. As you can see, we're going from a cap this big to a cap of this big. This is an audio grade cap by MKIII. And again, I'm not sure why they had a 250 volt cap on the cathode of this tube when it's never going to see over 23 volts. So this will be a much higher quality cap. It's really going to make it sound good. I do think one of the other upgrades I'm going to do to this while I'm in here is I'm going to go ahead and install some Mundorf coupling caps between the driver tube and the output tube. I'm not sure how much that's going to really help sonically, but I don't want to cripple this little amp with possibly a suboptimal quality coupling cap. And in the past, I've found that coupling cap upgrades do make a really nice improvement in the sound. Now, you've probably seen a zillion videos of people putting monster capacitors to replace these with that are like twice as tall. You know, they're 270, 330 UF. It's really not a good idea, in my opinion, to put capacitors that big in the power supply. It's just not needed. You've already got another pretty big one here, and it just puts a lot of excess strain on the power transformer, which is never a good idea. And so, yeah, we're going to leave those alone. And I think the changes we've done to the front end are going to eliminate the hum and noise that people are replacing these trying to eliminate. And from my understanding, it never really accomplishes that goal. So let me go find a 300K resistor and get it all prepped up to put as our shade feedback resistor, and then we'll get that soldered in and replace these two capacitors with some Mundorf units, and we'll be done with all the mods on this little amp. Okay, so we got our shade feedback resistor connected, and it is the 300K resistor that goes from this pin here, which is the plate of the output tube. It comes across here and it goes to this connection right here, which is where this 510 ohm resistor and this 33K plate load resistor connect to this terminal, which is the plate of the input tube. Same thing on this channel over here. We go from the plate of the output tube, 300K resistor, comes over here, ties into this terminal right here, which, as you can see with a little trace here, comes across, goes over here to the plate of this input tube. So this is where the signal gets pulled off of the plate of the input tube to go to the grid of the output tube, and it goes to this coupling capacitor here. And same thing on this channel over here. And we're going to upgrade from these little box caps to these Mundorf aluminum foil coupling caps. They're both 22 UF, 450 volts. Just these are much higher quality sonically. Have no idea what the sonic signature of these little box caps are. Don't even know what they are, who makes them. So we are not using those. Because again, I don't want this to cripple the potential sonic goodness that this amp has. So I did bend up the leads like this. I want to get this cap as far away from this cap as I can. And we use some PTFE tubing. And this little guy is going to sit just like that. And we're going to put one over here on this side, just like this. And then when we get done, probably going to get my hot glue gun and just put a little glob of glue here to give these a little support so they're not just dangling up there in the air. But it is important too to make sure that the writing is going in this direction. And on these caps, the start of the writing is the outside foil of the cap. These are non-polarized caps, so they'll work in either direction, but if you install them in this direction, it'll help keep noise from getting into the grid of the output tube. So we're going to solder these two guys up. So like I said, I'm going to come in here with a little hot glue, fill in this little gap right here, give it a little support, and we'll have this board all modified and ready to put back in the amp. Okay, we got the transformer bolted back down. We got the wires run over here. We have this heater. We've got the plate, ultralinear tap B+, plate, ultralinear tap B+, and blue, brown, pink. The wire colors are different on this side because I was thinking I was going to be replacing these for sure, so I cut the wires, but I left enough out so I could splice these in. So just kind of ignore these colors over here, but we've got these colors the same on both sides. Now we're ready to put the, this is the high voltage, these two red ones. And again, I marked them with a little paint marker before I took them off. Even though it's AC, it shouldn't matter, but I just wanted to hook them back up like they were. Then we come in here and put these 4 Phillips head screws in to hold the board down. Go ahead and get them all started before you snug them down. And you can see our fancy Mundorf coupling caps, which I hope those things help the frequency response a little bit too. We will see. And then once we get this thing all back together, The last segment in this video series, we are going to play around with different tubes and see what that does as far as the distortion and the frequency response. So you want to go ahead and plug this in here, and then this will come up here like this. We'll put the 4 screws on the front, and then make sure that you come in and solder this blue wire back there. So let me go ahead and get a screw put in here in the front to kind of hold this in place. And on these front ones, definitely do not tighten these up until you get them all started, because they are a little weird trying to get them all started. You might have to pull the chassis kind of in and out a little bit on this end here to get this one started. There we go. And I'll put those other 2 in off camera. But let me go ahead and solder this wire in place to show you where it goes. Just like that right there. You want to make sure you leave a little mound of solder here to attach this blue wire. And then these are going to come up here. I need to trim this off and get these to a nice length, and then wrap these back up. And yeah, I think we'll be all done here. So let me get this stuff all tied up, wrapped up, screwed up in the front with the extra screws, and I think this is a great place to wrap up this video. Well, as you can see, these mods aren't super difficult to do, and hopefully I did it in a detailed enough way where you guys can follow this at home. So the question you're probably asking is, hey Skunky, how did this thing turn out? It sounds a lot better than I was expecting. And I'm not sure if changing that coupling cap helped pull the frequency response down lower. We're going to be testing that on the Analog Discovery 2 on my old ThinkPad laptop here in the next video, as well as going over some tube rolling recommendations. I did some listening tests both with headphones and with speakers, and we got a little different tube selection for one versus the other. It could just be that my headphones have a little different frequency response than my speakers do, and we were tuning for that. Also, it could be that we're operating in a lower portion of the volume knob, and the gain being used by an amplifier can affect how it sounds as far as the tubes being used. So if you're using it more as a background, low volume kind of setting amp, you might use different tubes than if you were trying to drive some speakers to 80 to 85 dB in the room. So anyway, I'm pleasantly surprised at how this little amp turned out. Does it sound like a $2,000 amp? No, still sounds like a $500 amp. And honestly, I'm not sure if the Bowyer range of the Rysong A12 modified wouldn't sound better than this. But I don't have one here to A/B listen, but just from memory, I think it sounded a little cleaner. But hey, for the price of this amp, especially if you already own one, do these mods. It's going to make a huge difference in the way the amp sounds. You will note, after you do the mods, you're going to end up turning the volume knob up higher than you used to. Like if you had it at 30% before, you might be at 3/4 volume to get the same sound pressure level in the room. But before, anything over about 1/3 volume was into heavy clipping and distortion anyway. So it's not like you're getting less power, but it's probably a less perceived power. And I think that's one of the reasons a lot of these made in China amps have super high input sensitivity, is to fool you into thinking the amp has way more power than it actually has, because you're like, oh, I never turn it up past 1/4 volume. This thing must have a ton of power, when in fact, really doesn't have a lot of power. It just goes into distortion at a third volume, so you think it does. It's got like 2/3 of the volume knob that's unusable. So don't be fooled by that. And triode strapping these driver tubes really hugely improves the sound. I will say before I get into the video about tube rolling, these Horizon tubes sound really quiet. And I believe it's got something to do with the way the heaters are constructed and that there's no leakage between the heater insulation and the cathode, which some tubes there's a little leakage there and you hear some hum. So if you're looking for silence out of one of these amps, even unmodified, give a pair of these Horizon tubes a try. I like these Sylvania 6SJ7s just as a general all-around tube. If you need something that's a little brighter, these 5693 red RCAs work really well as well. I tried some mesh plate tubes, wasn't real crazy about them. Stock tubes, wasn't real crazy about them. So anyway, we'll get into tube rolling in the next video. Hope you've enjoyed this little series on this amp. If you have, please subscribe to the channel. Please like the video. If you found this information valuable, got a donation page on my website to help fund the money that I spent working on this thing. Ended up buying a pair of output transformers that basically I'm just going to have to give away or try to do some, probably throw them away. They're terrible. Anyway, live and learn. And you got to learn from my mistake. So anyway, having said all that, thanks again to you longtime subscribers, the folks that watch my videos. And we're going to wrap this up with one more video doing some objective testing and subjective thoughts on tubes. And until then, have a nice day.